Hey everyone, today I'll be covering the Fallback challenge from the Ethernaut, which is the first proper challenge. And I'll be solving this using Ethers.js and within the hardhat framework. I have a video on how you can set that up. That will be in the description below, so I'm not going to go into how I'm setting that up today. So let's have a look at this challenge. You will beat this level if you claim ownership of this contract and you reduce its balance to 0. So if we have a look at this contract, we can see there's a constructor, there's an only owner modifier. There seems to be a contribute function which will track our contributions to this contract. You can get the contributions of a particular sender. Oh, it's only yourself. And you can also withdraw. And it also has this function here called receive, which is what's called a fallback function. So that is what happens, the code that runs when this contract receives payment but has no function to run with it. So we need to become owner of this contract. And if we have a look at it, we can see that down here, we're setting the owner and we're also setting the owner up here. So there's two possible avenues that we may be able to exploit. Given that this is called a fallback, let's have a look at the fallback address here. So what happens is when this contract receives payment, but without a function call, it's going to require that the message.value, which is the amount of ether or amount of value being sent, is greater than 0. And the contributions of the sender is also greater than 0. So firstly, we need to set our contributions. We need to contribute something, and then we also need to send it again, and then we need to retrieve. We should be able to become the owner. So let's go ahead and do this. Let's get a new instance. And I'm going to set this to 2 as a complete guess. I got it wrong. So the nonce is too low, and I was meant to be 3. So let's get a new instance, hit 3 in our nonce, and we can see now we have a new contract address. Cool. Okay, so the next thing that we're going to do is we are going to create a new script which is going to solve this challenge for us. So I'm going to copy this template script that I have. This is just what I start all my scripts with. And we're going to paste in the address of the contract. And let's go ahead and rename this contract that we're using to be fallback. Okay, so what were the steps that we needed to do? We need to going back to the contract, we actually can have a look at it here in VS Code. So we are going to firstly, as again, we have a look here, we need to pay the fallback function, but we also need to make sure that our contributions are greater than 0. So let's go ahead and contribute some value. So there's a function here called contribute, and it requires that the message.value is less than 0.001 ether, and then it does the contribute. So let's go ahead and just do that. That should be pretty straightforward. So we can go ahead and go, let's just log what we're doing, sending a new contribution. And we're going to go await contract.contribute. And it doesn't have any parameters. However, there is an overload parameter that we need to pass in, which is where we can define our value. This is the last parameter of any function call within Ethers.js. And we can set our value here by going ethers.utils.parseEther, and it needed it to be less than 0.001, so we're going to do 0.0001. And so I'm just going to comment the code just so we know what's going on here, which is going to be sending a new contribution to meet requirement. Let's just format this. There doesn't need to be a semicolon there. And then what I want to do is verify that our contribution actually came through. So the way that we can do that is by running the get contribution function. So we're going to log console.log, and we're going to say current contribution. Yep, and then we can await, actually I'm going to put this in brackets, await contract.getContribution, and we don't need to pass anything fancy with that. We can just put in toString here because that's going to return a big number. We don't need to await that. Okay, so what this is going to do, again, send the new contribution. That's going to come through. Then we're just going to log to verify that that contribution went through. So let's go ahead and run this. So npx hardhat run scripts fallback .ts on the localhost network that we're running on. And you can see that it's sending a new contribution, and we can see that we have contributed. So you may think, whoa, we only submitted this amount of Ether. Why is this coming back? So this comes back by default in, I believe it's way. So way is 1/18th, or like 18 decimal places below 1 Ether. So that's just kind of the lowest unit of within like Ethereum, I guess. Okay, so now that we have the contribution, the next thing that we're going to need to do is run the fallback method. So how do we invoke the fallback method here? So we now know that our message value, well, we're going to need to send a message that's greater than 0, and our contribution needs to be greater than 0, which we should have met, and we should become the owner. So what we're going to need to do now is create a new transaction. So there's no way to call a contract directly's to call a contract's fallback function. You just need to create a new transaction. So I'm going to create a new transaction of type transaction request. That's how you spell it, I'm pretty sure. Why is that not importing? No? Okay. Anyway, in this transaction, we're going to have a to. And this is where this transaction, who this transaction's for. So we're going to put in the contract address here. And we're also going to put in our value, which is also going to be, if we go to the contract, needs to be greater than 0. So we can just put in, again, ethers.utils.parseEther. And we can just put in the same amount that we put in before. Very confused as to why this is not importing. Anyway, we can get rid of that for now. But that is actually, this is a type of transaction request. I might be able to, no, there's no way. Okay, so the next thing that we're going to need to do, I think I should just be able to copy this. So this is just from another project that I've got. No? Maybe? There we go. Okay, so that looks like it's all good. So now we have this transaction request. We now want to send this transaction. So the way that you send a transaction is, again, we have this signer address. So this is like our private key, our kind of wallet in this context. So we're going to use, we're going to await signer.send a transaction, and the transaction we're going to send is the transaction that we've just defined above. And that's it. So once that's done, that's going to send the transaction. Ideally, then the owner should become us. So once that's done, we can then get the owner. So check owner. So we're going to create a new variable called owner, and it's going to await contract.owner, because owner is a public variable that we can read. And once we have that, we want to verify that if the owner is equal to the player address, then we want to withdraw all the funds, because that is what is required. So we need to reduce the balance of this contract to 0. And the way that we do that is we just hit the withdraw function, which transfers to the owner the entire balance of the contract. So that's pretty handy for us. So let's go ahead and we can run await contract dot withdraw, and then we can verify the balance is 0. So once that's done, we can then go the balance is equal to await. There's no direct method for this, so you have to use your provider. So ethers.provider.getBalance of the contract address. And then we can console.log the balance of the contract address is, and just pass in the balance there. So again, let's run through our scripts and see what happens. Firstly, we send a new contribution to meet that requirement, so we can do the payable, the fallback payable address. Then we just get the contribution to see what it is. We then create a new transaction, which will pay to the contract's fallback address. We then, after that, we should become owner, so we can set the owner to ourselves. Well, we just check the owner. If indeed this all works, then the owner is equal to us, and we can go ahead and run the withdraw method, which will then empty the balance of the contract. So let's go ahead and run this again. And so we can see we're setting a new contribution. The current contribution is 2 because we already had the 1, whatever value that is from the last time we ran this. It's now 2. And then we can see we did get into this if clause, and it said the balance of the contract address is now 0. So we can come back here and submit the instance to check that we got this correct. I believe we're up to maybe like 5 or something now. Nope, nonce is too low. We need to go set it to 8. And bang, that's how we solve this. Cool, thanks.